Hello and welcome back. This is Saxon Math Lesson 46, Writing Decimal Numbers in Expanded Notation, as well as mentally multiplying decimal numbers by 10 and 100. We may use expanded notation to write decimal numbers just as we have used expanded notation to write whole numbers. The values of some decimal places are shown in this table. So the ones, the tenths, the hundreds, the thousandths. So this, let's say you had this would be 1,000ths, 1,000th. Or we can write 4 and 25 thousandths in expanded notation. So if we had 4 and 25 thousandths, it would look like this as a decimal. And expanded notation would look like this: 4 times 1 in parentheses plus 2 times 1/100th in parentheses plus 5 times 1/1000th in parentheses. The 0 that serves as a placeholder, this one, is usually not included in expanded notation because it would simply be 0 times 1/10th, and 0 times anything is 0, so therefore they just don't include it in the expanded notation. So if we were to write 5 and 6/10ths in expanded notation, you simply take the 5 times what place value is it in? It's in the ones place. 5 times 1 plus. We don't have to do 0 times 1/10th, but we do need to do 6 times 1/100th. It's in the hundredths place. So the expanded notation of 5 and 6/100ths is 5 times 1 plus 6 times 1/100th. So 5 being in the ones place, just multiply it. 6 times the 1/100th place is what place value it's in. So we say the word "and" when we're using decimals. So you read 5 and 6/100ths. And we know that this is the hundredths place. So that's the word that you would use when describing it. Example 2, write 4 times 1/10th plus 5 times 1/1000th as a decimal number. So there are no whole numbers in this case. I'm going to start with 0, and I can see that the 4 has to be in the 10th place, and the 5 has to be in the thousandths place. So here's the hundredths place. There are no hundredths, but there is a thousandths place. So I have to make sure I use 0 as a placeholder. I need to know that this is the 10th place, the hundredths place, and the thousandths place. So because of that, it is now technically this would be 4/10ths plus, if you were to look at it in thousandths, that would be like this: 4/10ths plus 5 thousandths. And if you did that, 4/10ths plus 5 thousandths looks like this. And the 5 would be here, there'd be 0 here, 4, the decimal would be there, it'd be 405 thousandths. So just make sure you write the decimal number with a 4 in the 10th place and the 5 in the thousandths place. No digits in the ones or the hundredths place are indicated, so you would simply write zeros in those places. Let me make sure we got all of that. Yep. And next item, we're looking at mentally multiplying. When we multiply whole numbers by 10 or 100, we can find the product mentally by attaching zeros to the whole number we were multiplying. So 10 times 24 equals 240. We're just attaching another 0. We're attaching 1 0 to be exact. Or 24 times 100, we attach 2 zeros because there's 2 zeros in the 100. So 2 zeros are attached to 24. It may seem that we're just simply attaching zeros, but we're actually shifting the digits to the left. When we multiply 24 by 10, the digits shift one place to the left. When we multiply 24 by 100, the digits shift 2 places to the left. In each product, zeros hold the 2 and the 4 in their proper places. So, for example, 2 is in the tens place and the 4 is in the ones place. If we multiply it by 10, we're simply shifting the 2 to the hundreds place, and the tens place now has the 4, and the ones place is going to have 0. If we multiply it by 100, we're going to have a 2 place shift. So the 2 would be in the thousands place, the 4 would be in the hundreds place, the tens place would have 0, the ones place would have 0. When we multiply a decimal number by 10, the digits shift 1 place to the left. When we multiply a decimal number by 100, the digits shift 2 places to the left. Here we show the products when 24 hundredths is multiplied by 10 and by 100. So if you're looking at the decimal 24 hundredths, this is the original decimal. If you were to multiply that decimal times 10, you shift the 2 and the 4 1 place to the left. Or technically, you could actually consider it being shifting. If your decimal starts in this position, it's like you're moving it 1 place to the right as well. So 2 and 4 tenths is what 24 hundredths times 10 equals. If you're multiplying it by 100, you shift it 2 places to the left. And in doing so, you would have 24 with no tenths, and no hundredths. Although it is the digits that are shifting 1 place or 2 places to the left, we get the same effect by shifting the decimal point 1 or 2 places to the right. So you could say 24 hundredths times 10 is the same as starting point right here, 24 hundredths, shifting 1 place to the right, and you'd have 2 and 4 tenths. Or if you're multiplying by 100, 24 hundredths, shift 2 places to the right, you'd end up with 24. This is a 1 place shift, this is a 2 place shift. You could consider that that's 1 place, and this is 2 places right there. Example 3, multiply 3 and 75 hundredths times 10. So if I'm just going to use the example before and just shift to the right 1 place, I know that this is going to be 3 and not going to have the decimal in the same position there. It's going to be in this position now, 37 and 5 tenths. And if I was to move the digits to the left, that's the same effect. I'm going to move them left 1 place because there's 1 0. 1 0 means 1 place to the right, or shift all the digits 1 place to the left. Since we're multiplying by 10, the product will have the same digits as 3.75, but the digits will be shifted 1 place. The product will be 10 times as large, so we mentally shift the decimal point 1 place to the right. So 3 and 75 hundredths times 10 is 37 and 5 tenths when shifting 1 place. We do not need to attach any zeros because the decimal point serves to hold the digits in their proper places. So we don't have to add any more zeros to that one. Example 4, multiply 3 and 75 hundredths times 100. So my favorite way to do it, you can do it however which way you want. I noticed that this needs to be shifted 2 places, and I'm going to say 2 places to the right because it's a multiply. So because it says multiply, it's 2 places to the right. The decimal is originally in this position right here. And if I move it 1 place, it'd be here, but I have to move it 2 places. So it'd be 375. I don't have to put a decimal and a 0 there. 3 and 75 hundredths times 100 would be 375. When multiplying by 100, we mentally shift the decimal point 2 places to the right. So 3 and 75 hundredths times 100 equals 375. We do not need to attach zeros since there's no decimal places. We leave off the decimal point. Example 5, multiply, well, in this case, you've got 1 and 2 tenths divided by 4 tenths times 10 over 10. Well, what does 10 over 10 represent? Technically, it represents 1. But if we were to multiply these, we'd multiply the numerator and the denominator, and hopefully you know you're shifting the decimal one place to the right because each of those is just 10, and it's 1 0 in each of them. So this would be 12 over 4, and that simplified, 12 divided by 4 is 3. So the final answer would be 3. And just looking at the solution from the text, multiplying both 1 and 2/10 and 4/10 by 10 shifts each decimal point one place. The expression 2 divided by 4, or 2 over 4, means 2 divided by 4, which equals 3. All right, let's try some of these. Write these numbers in expanded notation. Letter A, 2 and 5/100ths. So expanded notation of this would be 2 times 1 plus 5 times, and in this case it's in the hundredths place, so I might take it times 1/100th, and that would be the expanded notation of that. Letter B, 20 and 5/10. This one you'd see 20 is the same as 2 times 10. That's the tens place. So you take the digit and you multiply it by the place value that it is in. So it's not 1 times 20, it's 2 times 10. It's in the tens place. There are no ones, but there is a tenths place, and that would be 1 over 10. And letter C, 205 thousandths. This one would be 2 times the tenth place, so that's 1/10, not tens, plus 5 times 1/1000th. That's in the thousandths place. This is the hundredths, this is the thousandths place. So it needs to be 5 times 1/1000th. All right, let's look at letter D here. Write these numbers in decimal form. So you have 7 times 10 plus 8 times 1/10. So in this case, all you have to recognize is that 7 times 10 is the same as 70, and 8 times 1/10 is 8/10. And if you were going to put that in decimal form, that would look like this: 70 and 8/10. And letter E, 6 times 1/10 plus 4 times 1/100th. You have to recognize that the first part is 6/10, and this part is 4/100ths. But you need to make sure that you put them in the proper position. So 6 is in the tenths place, would look like this. There are no hundredths, or sorry, there is the hundredths. Just getting ahead of myself there and going to the thousandths place. Let me back up here, make sure that this is clean. So we have 6/10, we have 4/100ths. 6/10 is in this position right here, right next to the decimal, and then the hundredths is right next to that. There are no thousandths, so this would be 64/100ths is what 6/10 plus 4/100ths equals. And if you didn't recognize that, 6/10 looks like this, 4/100ths looks like this. If you were to add those together, you would end up with this: 4 there, 6 there, decimal 64/100ths. All right, letter F. You should be able to mentally calculate this by recognizing that you're going to move the decimal one place to the right because it has 1 0 here and it says multiply, so we're moving the decimal to the right in the original factor here. So 35/100ths times 10. You should end up with 3 and 5/10 for letter F. Go ahead and do letter G, 35/100ths times 100. This one you should have gotten 35, because if you were to move the decimal 2 places to the right, because there's 2 zeros, you'd have 35. You don't need any 0.0 at the end of that. Letter H, 2 and 5/10 times 10. You should end up with 25, because if the decimal was in this position originally and you're going to move it one place to the right, it now becomes 25. Here's the decimal. We're going to move it one place to the right because it says multiply and it's by 10. There's only one place to the right. Letter I, 2 and 5/10 times 100. Should have gotten 250 for this one, because if the decimal again is in between the 2 and the 5 and I move it, in this case it says multiply, so that's to the right, and there's two places. So if I'm in this position originally and I move once, twice, it's now 250. And it makes sense because you know what 2 times 100 is? That's 200. So 5/10 times 100 would actually be 50. So you have 250. Letter J, 125 thousandths times 10. Should have ended up getting 1 and 25 hundredths, because if the decimal is in this position just to the left of the 1 and I'm moving to the right one place, I'd recognize it ends up between the 1 and the 2, which makes it 1 and 25 hundredths. Letter K, 125 thousandths times 100. You should have gotten 12 and 5/10 for this one, because again, if the decimal is just to the left of the 1 and you're moving it two places this time to the right, because there's two zeros in 100 and you're multiplying it, so that means you're moving the decimal to the right, you'd end up with 12 and 5/10. All right, letter L. If 4 hundredths is multiplied by 10, the product is a whole number. Is this true or false? The answer should have been false for letter L. If multiplied by 10, the product is a whole number. Well, a whole number is something that's larger than 1/10 or 9/10. It's going to be one whole number. If you multiply this by 10, you're moving the decimal to the right one, and it would end up being a decimal still. It'd be 4/10. And 4/10 is not a whole number. That's a fraction. That's a piece of a whole. So that's why it's a false answer. Letter M, if 4/10 is multiplied by 100, the product is a whole number. True or false? In this case, you should have answered true, because if you move the decimal two places to the right, you now have 4. 4 hundredths times 100 actually ends up being 4. And 4 is a whole number. Letter N, multiply as shown and then complete the division. So in this case, they want you to multiply the 1 and 5/10 times 10 and the 5/10 times 10, and then complete the final division answer. Okay, so for the top part, you should end up with 15, because you're moving the decimal one place to the right, and you're moving this decimal one place to the right in the bottom. So you have 15 divided by 5. 15 divided by 5 is 3, would have been your final answer. Letter O, 2 and 5/10 divided by 5 hundredths times 100 over 100. In this case, you would have recognized that 2 and 5/10, you're going to move the decimal two places, so that would be 250 for the numerators, because it's 2 and 5/10 times 100, and 5 hundredths, move the decimal two places to the right, you'd end up with 5 in the denominator, because 5 hundredths times 100 equals 5. Now if I was to divide those, I know what 25 divided by 5 is, that's 5. And then I have to remember there's still a 0 here, because all I did was take 25 divided by 5 in that case. So 50 would have been the final answer for that one. All right, nice job following along. If you missed anything or you don't understand something, go back to the beginning of this lesson and review some of it. We'll see you next time, and have a great night.